All right, experiment 5. Experiment 5. Solubility and solubility curve. Go through your manual. I would like to summarize this topic because it's very, very simple. And I can see that many of you actually understand it, at least to a very good point. All right, solutions are homogeneous mixtures of solvent. When you say solution, that means a solute have dissolved in a solvent. Okay, it could either give you an homogeneous solution. An homogeneous solution is the one whereby you don't see anything. As soon as you dissolve your solute, everything becomes like the same. Everything is looking like water. You can't find, like when you dissolve your salt in water, after some time you can't see a grain of salt. Everything has gone. So it is all in the water. So that is an homogeneous solution. Whereas you have another type of solvent which is heterogeneous. In heterogeneous solution, you have your solute dissolved in your solvent, but you can still actually pick out one or two things. Yeah, if you mix sometimes when you dissolve your beverage in water, sometimes not all the particles of the tea will dissolve, except if you use hot water. So you can still find some crumbs here and there. So that is heterogeneous because you can still see some things that refuses to mix with your solvent or to dissolve in your solvent. As water molecules collide with ionic compounds, e.g. sodium chloride, the charged end of the water becomes attracted to all those blah blah blah. That is chemistry. Now we want to look at solubility. Solubility is the quantity of solute that dissolves in a given amount of solvent at a particular temperature to form a solution. When you're talking about solubility, you must remember that there are certain factors that affect solubility. The nature of your solvent will tell you how far the solubility will go. The nature of the solute will also dictate the amount of the solute you are putting in. And that is to tell you that there are some things we call saturated, unsaturated, supersaturated solutions, okay? Depending on the amount of solute, all right? Then temperature is also a very important factor that affects solubility. If your temperature is not where it's supposed to be, your solute will not dissolve. And if it is too much, expect another reaction. Right? Then the last factor is pressure, and that is actually for gases. Now there is another term I can find in our manual, solvation. Solvation is different from solubility. Solvation is the solution that is going on. It is a process of dissolution in which a solute dissolves in the solvent, whereas solubility is the quantity of solute that dissolves in a given amount of solvent at a particular temperature to form a solution. All right, you are given some test tube and blah blah blah. You are asked to find crystallization temperature. I am not sure if there are up to 10 people, 10, that would be too much, that actually got the crystallization temperature correctly. But fine, you were fined with a minus half for all of you that did the question wrongly, that got the temperature wrong. You were fined half mark. All right, you were penalized for half mark. So, but your graphs were still marked and your calculations were okay to a very good extent. Now, you are asked to convert your mass per 5 cm cube or mass per 2.5 cm cube that you were actually given in the lab to mass per 100 cm cube. It's a simple ratio thing. I'm sure you got it. Now you have to plot your graph. I remember in chemistry class, in chemistry laboratory, I emphasized the importance of your graph title, the scale. but majority of you still did not do it. If this kind of question, I'm sure you did it in O level. How can you plot a graph without title, without the scale? It only means you copied someone, because if you actually did it well, you will take your time to give your graph a title and to let the marker know the scale with which you are working. So it's very important when you're plotting your data to put in your title of graph, your scale of graph, and show your solubility curve properly. Number 3, you have to construct a solubility curve by connecting a plotted point. Please ensure your solubility, the temperature of crystallization is correct. Otherwise, it will affect the kind of curve you will get. Now, in question 4, you are asked to determine the solubility of KNO3 as the temperature rises. It's just for you to trace it on the graph. That's what they said, according to your graph. According to your graph. How does the solubility of KNO3 change as the temperature rises? Definitely, as temperature rises, solubility will increase. That is one thing you should know. The more you increase the temperature, the more, okay, let's come back to our hostel. You want to make tea. This is Bonvita. This is cold water. You try, I'm sure you have done it many times. Try and dissolve your Bonvita in water. You know you have to expend energy to do that. You have to be mixing and mixing. In fact, you will get impatient, you start eating your Bonvita yourself and drink the water that follows. But if you get hot water, just drop your Bonvita. You don't need any energy. The Bonvita will dissolve. So please, solubility increases as temperature rises. Number 5, using your graph. How many grams of can this you have to do through your, using your graph, you have to trace from the 40 degrees, you trace it to where the mass is and get the correct thing. But if your solubility curve is wrong, it will affect the values you will get in number 5. Number 6, on your solubility curve, what is the change in solubility from 30 degrees centigrade to 60 degrees centigrade? It's just for you to trace what 30 degrees centigrade is giving you, what 60 degrees centigrade is giving you, and take a difference, and that is your change in solubility. You don't have to start dividing anything like some of you did. On my own graph, I got 60 degrees centigrade gave me 106 per 100 cm cube, whereas 30 degrees centigrade gave me 16. So on taking the difference, I have 90 degree per 100 cm cube. You may get something that is different from that. You will not be penalized so long your graph is telling us what you are doing. Because you cannot just think you give an answer that does not correspond with what you pointed out on your graph. This will be taken into consideration. Question 7, using your graph, how much KNO3 must be added to make a saturated solution at 55? Just trace and get your answer out. Then you have to define saturated, unsaturated, and supersaturated solutions. Saturated solutions are solutions in which a given amount of solute is completely soluble in the solvent at a given temperature. That is your saturation point. An unsaturated solution is a solution in which the amount of dissolved solute is less than the required amount for saturation to take place. Then supersaturation is a solution in which the concentration of the solute exceeds the concentration required. Supersaturation, when you are drinking your garri and you put garri with small water, before you say Jack Robinson, the garri has swallowed up your water. That's supersaturation because your solute is more than what you need to actually dissolve in that water. So that is the difference between saturation unsaturation, and super saturation. So that brings us to the end of the audio revision classes 2 for today. God bless you.